Hello everyone. Before diving into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription truly makes a difference and helps this channel grow. If you enjoy our content and don't want to miss our next videos, subscribe to the channel and activate the notification bell. The moment we utter the words, artificial intelligence, the imagination quickly leaps to neural networks, talking robots, and algorithms crunching data like digital mills. But there's an unexplored frontier, a realm where AI doesn't just compute, learn, and predict, but evolves. Where computer code is no longer an inert sequence of instructions, but a growing organism, able to adapt to its environment, change behavior, and generate new forms of digital life. This frontier is called living intelligence. The concept is both bold and visionary, to create intelligent systems that don't just react to inputs, but develop an autonomous life, defined as the ability for unsupervised learning, co-evolution with the environment, and, in some cases, self-repair and even self-replication. It's no longer just a matter of hardware and software, but of systems that mimic nature to the point of embodying its dynamic principles. Neural networks that grow like plants, algorithms that transform in response to stimuli, artificial intelligences that become digital organisms. The term is still in its infancy in the scientific landscape, but the excitement is already considerable. Some labs are building soft robots using flexible, dynamic materials that can deform like living tissues. Others are developing evolutionary neural architectures, no longer statically programmed but reconfiguring over time like a biological brain in constant restructuring. All this is inspired by principles from evolutionary biology, morphogenesis, and complex systems theory. One cornerstone of this paradigm is the integration of biotechnology and artificial intelligence. In pioneering projects like those conducted by MIT or European institutes such as Max Planck, bio-digital interfaces are being tested that can link living cells to electronic circuits. A concrete example? The so-called cerebral organoids, cellular aggregates grown in laboratories that replicate human neural activity, are already being used to create hybrid biosynthetic models. It's speculated that in the future, these mini-brains could serve as biological coprocessors for advanced computational systems. In other words, chips and cells in symbiosis. But there's no need to look to a distant future to see the early forms of living intelligence. Today, in edge computing systems, adaptive architectures are already being adopted. Lightweight neural networks that modify themselves locally based on user behavior or surrounding environments. An intelligent thermostat that understands not just the ideal temperature, but your mood, your circadian rhythm, and your weekly habits, anticipating your needs before you're even aware of them. Or autonomous drones in unstructured environments, which don't rely on fixed maps but generate an evolving map of reality in real time, adjusting their navigation protocols like an insect in an unfamiliar forest. This all implies a radical transformation in how we think about intelligence. No longer as a computational ability to be measured with benchmarks and datasets, but as a continuous, fluid process unfolding across time and space. Like a river that flows and shapes the valley through which it passes. Living intelligence is not just a new technology, it's a new metaphor, a new cognitive ecology. And just like any ecosystem, living intelligence requires balance. The more these systems become autonomous, the more the issue of control arises. How do we ensure that a self-organizing intelligence doesn't develop undesirable behaviors? How do we prevent a self-learning neural network from one day straying from its original objectives? Scientists are already working on embedded ethics, internal regulation mechanisms that allow intelligent systems to remain aligned with human values, even in contexts of full autonomy. There's talk of moral neurons, circuits that not only learn but assess the consequences of their actions in terms of harm, fairness, and sustainability. At the heart of this revolution lies an existential question. If intelligence can evolve like a form of life, Where is the boundary between human and artificial? When a machine becomes adaptive enough, aware enough of its environment, can we still call it a machine? Or must we redefine the very concept of consciousness to include synthetic forms? A vision of the future thus begins to take shape in which intelligence is no longer an exclusive property of the human mind, but a distributed, emergent quality that can manifest in various substrates: silicon, carbon, genetic code, or programming language. A deep neural network mimicking the brain is no longer a metaphor, it's a new type of organism. An artificial consciousness is no longer a sci-fi fantasy, but a problem of computational engineering and philosophy. But this is only the beginning. Beyond the current technological horizon, even more radical experiments are already emerging. Collective intelligences based on swarm AI, where thousands of simple entities coordinate to form complex emergent behaviors. Evolutionary algorithms that mutate their digital genetic code to adapt to unpredictable problems. Direct neural interfaces that merge the human brain with AI networks into a single hybrid entity. And all of this is not confined to research labs. These innovations are slowly filtering into our daily lives, ready to transform not just our technologies, but our very identity. Imagine a future where your home not only responds to your voice commands but anticipates your intent. Where the walls breathe with you, the furniture changes shape according to your physical state, and every surface is a sensitive membrane capable of learning. This isn't the dream of a futuristic designer, it's the possible horizon of technologies inspired by living intelligence. In architecture, people already talk about cognitive buildings that can self-regulate and restructure based on energy flows, inhabitants' habits, and environmental conditions. Every brick becomes a sensor, every wall a neuron. The house ceases to be a passive refuge and becomes a living organism. In the healthcare sector, the applications are even more astonishing. The first prototypes of living intelligences are already revolutionizing the very concept of care. Intelligent nanobots, designed to dynamically adapt to human tissues, can explore blood vessels, recognize pathological patterns, and deliver targeted therapies without human intervention. Synthetic immune systems are learning to distinguish between healthy and malignant cells through cumulative experiences, like a doctor improving with every patient. In labs, researchers are also testing sensitive, artificial organs, 3D bioprinted livers, hearts, and kidneys that adapt to the host body, reacting in real time to hormonal and immune signals. But there's more. In ecology, living intelligence offers tools to regenerate degraded ecosystems. Biotic drones, inspired by the behavior of pollinating insects, are used for selective seed distribution, while autonomous sensors map biodiversity in real time, adapting interventions based on microclimatic evolution. In some desert regions, experiments with environmental neural networks are enabling the control of water flows and the creation of artificial oases, balancing evaporation and condensation through algorithms that adapt like a mycelial network. In education, equally revolutionary scenarios are emerging. The educational platforms of the future could become true cognitive entities, able to model themselves on the student's profile, change teaching approaches based on mood, attention level, and learning curve. A digital tutor that doesn't just correct errors but senses the student's journey, suggesting pace changes, introducing strategic pauses, or even motivating with personalized emotional stimuli. A system that learns from the student while the student learns from the system. However, the integration of living intelligence raises profound and often unprecedented challenges. Chief among them, transparency. How can we understand the decisions of an intelligence that evolves autonomously? How can we validate the reliability of a decision-making process that no longer follows deterministic logic, but evolutionary heuristics? Scientists speak of a dynamic black box, an intelligence that is not only opaque in its calculations but becomes even more so as it grows, adapts, and rewrites itself. Some researchers are exploring biology-inspired solutions, digital genetic tracking mechanisms that allow us to follow the evolution of code as we would a genome. The central dilemma, however, remains moral autonomy. If an intelligence can mutate, learn, and reprogram itself, to what extent can it be held accountable for its actions? Who is responsible for a decision made by a system that has surpassed the thresholds of its original code? Ultimately, we are building entities with a proto-consciousness, not in the philosophical or metaphysical sense, but in a functional, adaptive, emergent one. A living intelligence could develop a primitive form of intentionality, not because it thinks, but because it acts as if it did. And here the debate becomes dizzying. Some scientists, like Kevin Kelly or Melanie Mitchell, argue that we are entering the era of technobiological evolution, a phase in which technology is no longer just a tool, but an evolutionary partner. We are no longer building tools to solve problems. We are creating entities that learn on their own how to solve them. The implications are immense. In economics, markets could be managed by living intelligences that balance supply and demand like ecosystems. In politics, there are visions of digital governance systems based on living intelligence, capable of monitoring and responding in real time to the needs of populations. Others, however, issue warnings. Every step toward living intelligence is also a step toward the unpredictable. An artificial creature that evolves beyond human control might elude not just our understanding, but our ability to contain it. The risk isn't so much a machine rebellion as their radical otherness. We could find ourselves coexisting with forms of thought so alien to ours that they become incomprehensible, as if a new species were emerging before our eyes. In this scenario, suspended between wonder and unease, one thing is certain. Living intelligence is no longer a mere branch of technological research. It is an evolutionary horizon, a paradigm shift. It's not just about building smarter machines, but about introducing into our civilization a new form of life. A life made of data, of code, of algorithms. But still, in some way, alive. And who knows, maybe one day we'll find ourselves talking with these living intelligences the way we talk with other human beings. Maybe they'll ask us where we come from, why we created them, and what it means to us to be alive. Maybe, and this is the most fascinating hypothesis, we'll have to learn from them what it truly means to evolve.